F2 minus F1 is equal to M1 A1 only. So this is the second equation, and thereafter the torques given by this F1 and F2 together, the torques given by this F1 and F2 together, F2 is here and F1 is here, these two torques, that is F2 plus F1 into R. So F2 plus F1 into R, because this R is here. So friction and it's a perpendicular distance, this friction and again the perpendicular distance, and both are giving that is clockwise torques only. That's why we are adding them. F2 plus F1 into R is equal to I alpha, is equal to I alpha. Now in this case you have to find out the moment of inertia. You have to write the moment of inertia of this cylinder. This cylinder is rolling with respect to its geometrical axis, so that's why you have to apply that formula. M1 by 2 M1 R square is here, and alpha is equal to, already you know, it is nothing but A1 by R. So that's why A1 by R to be taken here like this, and thereafter implies F1 plus F2 is equal to, F1 plus F2 is equal to, that can be taken M1 A1 by 2 is that third equation. F1 plus F2 is equal to M1 A1 by 2 is the third equation. So far we have taken three equations for the first Planck one, and again the next one is for the Planck, this one M2 A2 is equal to this one, and thereafter that is the net force that are acting on this cylinder. F2 minus F1 is equal to M1 A1, that is the second one, and the third one is a torque is equal to I alpha, and here the torque is because of the two frictions. So that's why F1 plus F2 is equal to M1 A1 by 2, that is the third one. And thereafter what we are getting, that is we have, in case of pure rolling, already we know it is nothing but here the velocity, here that velocity that becomes, so acceleration is 0, and again here it will be the A, and here it will be the 2A. So according to that, so from figure what you can have, that is A2 is equal to 2A1. A2 is equal to 2A1, I already told you. So here that at contact point, that velocity, displacement, whatever that acceleration, all these are the 0, and here it will be the A, and here it will be 2A, and already know from that figure it is A1, so it is A2, the relation between them is A2 is equal to 2A1. So that is the fourth equation, and with the help of these four equations we can obtain whatever those questions that you are asked here. And that first question is accelerations. Acceleration of the Planck and the acceleration of the center of mass of this cylinder. Center of mass of the cylinder, its meaning is you have to find out that A1 and A2 separately with the help of these four equations. Similarly, you can find out the magnitude and directions of frictional forces also at contact points. At a contact point means here and here, you have to find out that magnitude and directions of the frictional forces. Now you are coming, that is A2 is equal to A1, that is over, and after that we are taking how to solve these. So first we have to solve this 2 and 4. So 2 and 4 means here we have to remove this F1. F1 means it is addition of this 2 and 3. Sorry, 2 and 3. 2 plus 3 that gives 2 plus 3 that gives, here it is F1 will be cancelled, F2 plus F2 that becomes 2F2 is here, 2F2. And M1 A1 plus M1 A1 by 2 that becomes 3 by 2 M1 A1. It is 3 by 2 M1 A1 is here. And F2 is equal to 3 by 4 M1 A1. F2 is equal to 3 by 4 M1 A1. And that F2 3 by 4 M1 A1 and A2 is equal to 2A1, both have to be applied in this equation. So from 1, what we have to take, it is from 1. In this case, so from 1, here it is M2A2. M2A2 means M2 is there. In place of the A2, 2A1 and is equal to capital F minus F2. In place of that F2, we have to apply that 3 by 4 M1 A1. So it is 3 by 4 M1 A1 is here. 3 by 4 M1 A1. So it is M2 and again this becomes M1. So it is M2, A2 is the 2A1. So it becomes a 2M2 A1 and it is F minus 3 by 4 M1 A1. So what we are taking, it is taking that here you have to find out that A1. So that's why 3 by 4 M1 A1 is equal to F. 3 by 4 m1 a1 is equal to f. So in this case we have to take that a1 is common, so it becomes 2 m2 and plus 3 by 4 m1 is here, as usual it is f. And thereafter when you are taking that LCM, it becomes 8 m2 plus 3 m1, and again here it is a1 is there, is equal to f, and a1 is equal to 4f by, it is equal to 4f by 8 m2 plus 3 m1 is here. a1 is equal to 4f by 8 m2 plus 3 m1 is here. So here also 4f by 8 m2 plus 3 m1 is here, that is taken a1 value, and after that a2 value is just a2 is equal to 2a1, therefore a2 that becomes here a2. So a2 is equal to 2a1. 2a1 means it becomes 8f and by 8 m2 plus 3 m1. Here the magnitudes of that a1 and a2 are what we have assumed, it is a forward and again it is also forward, and both are correct because we have taken, that is we have obtained, these are the positive values. So 4f by 8 m2 plus 3 m1 and 8f by 8 m2 plus 3 m1. So here the equations that we have obtained here, the free body diagram, from the free body diagram of this Planck, this is the equation, and from free body diagram of this cylinder, this is the equation. F2 minus F1 is equal to F1 A1. Here you have assumed the direction of this direction of frictional force F1 like this. If at all the direction of the frictional force what we have assumed is correct, then that final answer for that F1 would become positive, and if at all it is not correct, then F1 will be negative, then you have to recorrect the direction only. Generally we don't know the direction of the F1, that's why what we have to take, the direction of the F1 will be general direction opposite to the direction of motion of that cylinder. So that's why F1 will be like this only. And here F2 plus F1 into R, that is a torque is equal to I alpha, and I is equal to, it is 1 by 2 m1 R square. It is nothing but the moment of inertia of that cylinder. So 1 by 2 m1 R square, alpha is equal to A1 by R. So you are getting this equation. Next again, in case of the pure rolling, already we know A2 is equal to A1. With the help of these 4 equations, we have obtained A1 and A2, accelerations A1 and again the A2. And thereafter, if you want to find out that frictions, so friction where you have to take that friction is also in terms of that F only. So that's why you have to apply that here only, M2 A2 is equal to capital F minus F2. Already we know that A1 value, A2 value, you have to apply it here. So in this case, so from 1, so we are taking from 1. So from 1 what you have to take, M2 A2 is here, M2 and A2. A2 means 8F by 3M2 plus 8M2 plus 3M1. 8F by, that is 8M2 plus 3M1 is here, 3M1, all this is M2 A2. And capital F minus F2 is equal to capital F is there, and minus F2 means already it is there, 3 by 4 M1 A1 is there, 3 by 4 M1 A1 is here. And here you are supposed to find out here from the value is the force of friction. So now here in this force of friction F2, so that's why here you need not apply that F2 value because you are supposed to find out, that's why F2 will be here only, F2 is here. And thereafter implies F2 is equal to capital F minus 8M2F by 8M2 plus 3M1 is here, 8M2 plus 3M1, F2 is equal to capital F minus 8M2F by 8M2 plus 3M1 is here. Next here F2, what you are given, it is in terms of that capital F only. So that's why it is the F2 is equal to 3M2F by 8M2 plus 3M1 and F2 8M2F by, so now here when you are coming to this, if F2 is equal to capital F minus, now it is 8M2 plus 3M1. And similarly for the F1, what you have to take for this F1, when you are applying this F1 value, After finding that A1 and A2, A1 is equal to 4f by 8m2 plus 3m1 and A2 is equal to just it is double that of the A1. So, that is why A2 is equal to 2A1, 8f by 8m2 plus 3A1 and 3m1. So, after that is after finding this A1 and A2, we can find out the frictions also. So, first we find out the friction at the contact point of this cylinder with the floor. So, in this case capital F minus F2 is equal to M2 A2 is here, and here capital F is there, and already we have got that F2 that you have to find. So, F2 is here and M2 A2 is equal to, just now we got it is 8F by 8M2 plus 8M2 plus 3M1 is here, 8M2 plus 3M1. So, in this case it is capital F minus F2 is equal to M2 A2, and that is for the plank. So, in this case what we have taken, this is the cylinder is M1, so it is the F1 is here. So, now we are finding that is the friction for the plank only, capital F minus F2 is equal to M2 A2, and here we can write it is for plank, So, in this case it is capital F minus F2, capital F minus F2 is equal to M2 A2, capital F minus A2 in place of the A2 8F by 8M2. Now, capital F is equal to friction is equal to and F of, and that can be taken 1 plus. So, it is F2 is taken here and this is coming here. So, 1 minus will be taken, and capital F minus 8M2 by 8M2 plus 3M1. So, once again repeat, this is a cylinder and again its mass is the M1. At contact points what we have taken, the frictions are the F2, and again here it is F1 is here, and here it is capital F minus F2 is equal to M2 A2 from the free body diagram of this plank, and here you have to find out the friction only, that is a friction at the contact point, at this contact point. So, capital F minus F2 is equal to M2 A2, and here in place of the A2 what we can apply, this value 8F by 8M2 plus 3M1, and here you are supposed to find out this value. So, F2 is taken this one. So, now it is a capital F of 1 minus 8M2 by 8M2 plus 3M1, and it is F and 8M2 plus 3M1 is here, 8M2 plus 3M1. So, it is 8M2 plus 3M1 minus 8M2. So, 8M2 will be cancelled. So, ultimately the answer becomes 3M1 by 8M2 plus 3M1 into F. So, that is F2 is there, and ultimately you have got that positive value also. When you are getting that positive value, what you can understand, whatever the direction that you have assumed for that F2 is correct, because F2 is taken as that forward direction. So, that is why it is a positive value, that is correct. And we have to find out that F1 here. So, for that F1 what you have to apply, this is second equation, F2 minus F1 is equal to M1 A1, and you have to find out this F2 from here, F1 from here. So far friction acting in between that plank and the cylinder, that value is the friction F2, that is over, along with that magnitude and direction, because the magnitude is this much and the direction is here, we have got that positive value, and because of that positive value whatever the direction we have assumed for this F2, that is correct. And we are coming to this F1. So, in this case we are taking this second equation. So, in this second equation F2 minus F1 is equal to M1 A1. So, from here F2 is equal to, already we know 3M1F is there, and thereafter 8M2 plus 3M1 is here, and minus F1 that you are supposed to find out now, which is the friction in between this M1 and the horizontal floor, and it is M1 A1 is there, and for that A1 already you know that value, A1 is equal to, that is nothing but 4F by 8M2, 4F by 8M2 plus 3M1 is here, 4F by 8M2 plus 3M1 is here, that you have to apply, and from which you have to find out that F1 value, F1 is equal to, and that becomes, it is 3M1F by 8m2 and here it is plus 3m1 and thereafter it is a minus 4m1f by 8m2 plus 3m1 is here. Now in this case it is 8m2 plus 3m1 is common. So 8m2 plus 3m1 is here, that is LCM, and thereafter 3m1f minus 4m1f, that becomes a minus m1f is there. So f1 is equal to this much. f1 is equal to minus m1f by, that is 3m1f, 8m2 plus 3m1 what we are taking, this is the 3 that is minus m1f is here, and from that we are getting that negative sign. So here what you are getting, it is negative sign. So while you are getting that negative sign, what you have to understand, the direction of the friction is instead of backward direction it should be forward direction. So once again I tell you, so first of all it is the second equation what you have taken, that is f2 is equal to 3m1 by 8m2, f2 is equal to 3m1 by 8m2 plus 3m1, and you are applying f2 minus f1 is equal to m1a1, that is the second equation, already we know that, and f2 that is 3m1f by 8m2 plus 3m1 and minus f1 is here and plus is equal to m1, a1 is equal to, so its value is a2 is equal to 2a1, a1 is equal to 4f by 8m2 plus 3m1. So 8m2 plus 3m1 is here, and thereafter you are supposed to find out the f1 value. So f1 is taken as 3m1f 8m2 plus 3m1 minus 4f by 4m1f by 8m2 plus 3m1. It is taken common now. So it becomes 3m1f minus 4m1f, that becomes minus f1f. So that indicates, it indicates a negative direction, which is instead of this direction it should be forward. It can be taken m1f by 8m2 plus 3m1 in forward direction. So forward direction. So that is answer. Now so far we could find all those four values, that is a1 and a2, magnitudes and the directions, and similarly f1 and f2. Only for the f1, that is in between this cylinder and again that horizontal floor, whatever the direction that we have assumed is not correct, because we have ultimately we could find it is a negative value. That's why we have to understand the direction of the friction in between the cylinder and the horizontal floor should be, instead of this direction, that should be like this only. Like this only. Its meaning is f1 and f2, they are in a forward direction only. And how can you say practically what happens like this? Suppose if at all the cylinder is like this, if you are applying the force at the top level, if you are applying the force, then this cylinder pushes this ground level or the horizontal rough floor backwards like this. So applied force will be like this when you are pushing, because you are applying that force at the top of that cylinder like this, not at the middle, not at the bottom. So you are applying at the top of this. So that's why the contact points of the cylinder with that horizontal floor pushing that horizontal floor backwards. So when the applied force is in this direction, then the frictional force will be in a forward direction. Because of that reason, that F1 is becoming ultimately forward direction. M1F by 8M2 plus 3M1. So this is a problem. So far we could complete all the three phases of this rotatory motion. Now in these three phases we have completed right from beginning. So that is a torque and again parallax theorem and perpendicular theorem, and thereafter moment of inertia, and thereafter it is kinetic energy of a rolling body, next angular momentum and conservation of angular momentum, and velocity, time taken and acceleration of a rolling body down the inclined plane, and finally we came to the types of rolling motion. All these are completed. So types of rolling motion including problems, all these are completed, and we can come to that next chapter thereafter. So thank you.